Hello everybody. This video is meant to try to make a relationship between the Drayon TPAC data set we've been using and the figure 9.1 from Salkind. Right? One of the nice things about the Drayon data set is that it can be used for many of the different branches and different kinds of statistical tests that are represented in figure 9.1. So I'm going to try to show different kinds of tests that you could use and how they relate to figure 9.1. Alright, the most important thing here is this question about, are you examining relationships between variables, key words between variables, or examining differences between groups? So it's between variables or between groups. Alright, so we're going to start with the left branch. I'm examining relationships between variables. Right? All right, I have simplified Ollie's data set because it's a very large data set, as you know. And for the examples I'm going to show, I'm going to use only the scale scores, which are made up of the averages of all the items that are in that scale. So if you look at my variable view, I've created a new SPSS file where I've taken out a couple of the demographic variables and I've taken out all the individual items, and all I have left is the scale scores. I also reversed the sequencing, so I put the post-test first because I'm going to be more interested in some of my examples in the post-test than the pre-test. But it doesn't matter, it's just the way that I organized it. So you see here I've got all the scale scores and none of the individual items. And if I look at the data view, same thing, much smaller, and that's going to make it easier for me to show examples of selecting the variables because those dialog boxes can be tricky when there's so many variables. Alright, so the first thing again is between variables. Now, just think about that literally for a minute. This is a variable, this is a variable, this is a variable. And so when we say between variables, we mean like between this variable and this variable. And so an example of that is a correlational analysis. So I'm going up to, you can't see it on my recording here, but I'm going up to Analyze, Correlate, Bivariate 2. All right, and now you can see. And suppose I wanted to know what is the correlation between the content math knowledge and I think this is science knowledge, content science knowledge. That's between two variables. So I'm on the left-hand side of the Salkind scheme. Right? And I run that analysis, and I find that the correlation is 0.1, very small, and that is actually logical because there's no reason that knowing math means I know any other content area. All right? Although I guess a lot of people would say that science and math are related, but you know, just because I can do an equation doesn't mean I know anything about earth science. All right. So that's a logical outcome, and the point is it's between variables. Now, let's go to the other side of Salkind's map. Well, no, I don't want to cancel it. All right. I'm going to show you this later between more than two variables, but I want to go to between groups. And there's a lot of different ways we can look at groups in Ollie's data set, but I'm going to look at the one that we're doing now, which is between two groups that are taking the same test more than once. All right? So, sorry, I'm having trouble getting back to my data set. All right. So groups in this case might be the different semesters that people took the test, took the survey. So I could compare semester 1 to semester 2 or phase 1 to phase 2. Or I could be considering the groups to be the group that took the test, the survey, at the beginning of the semester and how they did at the end. So I'm actually comparing average scores on the survey at the beginning versus average scores at the end of the same people, right? And the same, here's the key, the same variable. So I know the way I said that, it sounded like I was talking about between variables, but I'm not, because I'm comparing the groups on the same variable. So in other words, TK, let's do the big one, which is TPCK. If I want to compare TPCK, the same variable, from beginning to end, I'm going to use TPCK post and TPCK pre. Right? So again, you can't see me doing this analysis, but I'm going to analyze, compare means, paired samples t-test. And you guys did this well. This is a complicated test, but you did it well in your analysis. So I'm going to do this one, and I'm going to compare it to the same thing. All right. So this is not between variables. This is the same variable with two different points in time being tested. And I get data that looks like this. So I've got the mean of the first group. Mean is taking an average of a whole group of scores, and the mean of the pre-assessment. Another reason that I like switching the order there of having the post represented first is because then I naturally select post at the beginning and pre at the end, and then the subtraction is post minus pre, as opposed to pre minus post, and you have to reverse the negative sign. So this is kind of nicer. So the post is more than the pre, that's the key point. And the difference between the two, 0.185, is essentially the gain score. And the significance is obviously less than 0.05. All right, so what we just did was examine the difference between groups being tested more than once, and how many groups just pre and post. We didn't do a pre-test, a mid-test, and a final test. That would be more than two repeated measures. We just did two, and that would be this one here. That's the key thing. Now I'm going to get a little more complicated, but if that's enough for you, just stop right there and get solid in your mind the difference between variables and between groups.